Hello all, welcome to my YouTube channel PowerBud. Today I am going to show you about the footprint creation in Altium. So before going to the details about the footprint creation in Altium, I just want to give you an overview about the footprint design guidelines. So let's check first about the footprint design guidelines, then we will check how to create a PCB footprint in Altium. Okay? So the footprint creation mainly depending upon the component type. So there are different types of components like SMD, through hole, mixed one. For example, SMD components are the chip resistor, capacitor, SOIC package, ICs. All these kind of components are SMD. Through hole components are through hole capacitor, through hole resistor, inductors, and transformer. All these components are through hole. Here you can see a through hole radial leaded capacitor. This is an electrolytic capacitor, and these kind of capacitors or these kind of through hole elements, we have to create a footprint which is compatible for the through hole placement. So the through hole elements, you have to create a footprint which contains through hole pins. You have to define plated through hole for placement of these kind of components. So here you can see the corresponding footprint in the right side. There are two pins, one is for the positive and one is for the negative for the electrolytic capacitor. For the electrolytic capacitor, first pin they have created a footprint with a rectangular pin and the second pin is circular. So first pin representing the positive pin, second is the negative. So in your PCB it will be easy to understand which one is the first pin, which is the positive pin. Okay, and in this footprint itself you can see the pin 1 marking. Generally there are two approaches. You can mark the pin 1 or you can mark the origin in pin 1 or you can mark the origin in the body center. Okay, body center will be like here in this point you can mark, otherwise you can mark pin 1. Okay, in pin 1. And here you can see the silk screen. Silk screen is nothing but the representation. So in the PCB, if you define the silk screen after the production, you can see the silk screen. Okay, and place outline is nothing. It defines the boundary of the component placement. Okay, and also if you increase this place outline little bit, you can define the clearance area also. These details I will discuss later. And for generally for footprint creation, what you have to do, you have to refer the supplier data sheet. Suppose if you don't have the footprint recommendation in your supplier data sheet, then you have to refer the IPC standard, that is for the footprint creation mainly. So you have to refer the IPC standards and you have to create the footprint if it is not available in the data sheet. And another one method is also there, that is a tricky method. What you have to do, you have to select an alternative part for the component which should be pin to pin compatible, sizes also should match. For that kind of component you can refer the alternative part datasheet and you can create the footprint. This is not a recommended method because sometimes you will create error because some datasheet will need special footprint recommendation. For that cases, then you have to directly approach the supplier and you have to ask what is the footprint recommendation. Okay, so here for radial leader capacitor, if you don't have the recommendation, you can refer this IPC standards. There are some calculation available. Based on this calculation you can define the footprint. Similarly for radial element, like for radial element, there are footprint recommendation for axial leader elements. Here you can see axial leader will be like the width of the component will be large compared to the, the height of the component will be large. The length of the component will be large compared to the width. And for the radial element, the height of the component is large compared to the width. So I hope you understood the difference. For these kind of elements also you have to refer the IPC standard if it is not available. So this is the some standard and some calculations. If you are confused with this, just skip the topic for now. Later if you need some special, like if you need some footprint recommendation, at that time you can refer this and you can define the footprint. And for the plated through hole, there are some standards to define the through hole, like how how to define the drill hole, what is the annular ring size. These details also you can refer this. And for the SMD components, this is the SOIC package, and if you are a beginner, you may be confused what is this SOIC. So there are some naming representation for the footprints. For example, for the chip capacitor resistor, there are 0603 size code, 0805, 1206, 1210, etc. There are that size is increasing based on the increased size in the component. Okay, and similarly for the SMD components, there are different type of packages like SOIC, TO263. These kind of packages are there. So you have to understand this SOIC is the case code. Okay, for this kind of components also, for IC, my strong recommendation is you have to strictly follow the datasheet, because for ICs there will be chances of special datasheet recommendation. In that case, don't refer the alternative part datasheet. You have to directly approach the supplier and you have to ask the datasheet recommendation. And here, what are the important details available? The pin details available. Pin 1 they marked with a rectangular. This is not a mandatory rule, but if you want to create a standard library, you can create like this: pin 1 rectangular, other will be oval shape. We have a silk screen. We have a pin 1 marking here, boundary here, courtyard boundary here, and this courtyard excess. This is what I meant earlier. If you increase this courtyard size little bit based upon the standards, you can define the clearance also. So suppose if I am placing a component very close to this pin, there will be chances of short, right? So to avoid this kind of short, you can use an excess clearance here. Okay, this also I will show you later. And for the chip capacitor resistor, if the standards are not, if the datasheet is not recommending anything, means you can refer IPC SM78D2. If datasheet recommendation is available, means not available, means we can strictly follow this. This is very good document which show all the details about the chip resistor, capacitor, inductor, land pattern creation, that is the footprint creation. Okay, and these are the main things. Now the thing which you have to consider is you have to define based upon the soldering techniques. This is little bit advanced. Okay, suppose if your product finally you are going to manufacture with reflow soldering or wave soldering, based on that you have to define the footprint. So in some footprint recommendation, the supplier will define the reflow soldering recommendation and the wave soldering recommendation. So this is purely depending upon the soldering technique which you are going to follow in the final production. Okay, I'm not forcing you to refer this now. This is just an information I am sharing to you. Okay, later you will need this. Okay, finally once you define the footprint, it will be like this, but I will come back to this image later, because here are some errors are there. How to correct those errors I will show you. Okay, and for the solder paste definition, yes for SMD, no for plated through hole. Okay, generally when you define a solder paste area, what the manufacturer will do, like the PCB fabricate for the assembly process, what they will do, they will create a stencil, and on top of the stencil, so what they will do, they will place the PCB first, then on top of that they will place the stencil, and then on top of that stencil they will apply the solder paste, that the lead paste. Okay, so once they apply the lead paste, they will remove the stencil, then they will place the component on top of that footprint area, then they will solder it. So generally the soldering method is like through oven only, like reflow oven will be there, through that oven only. In that time it will pass through different temperature region, and finally the solder paste will melt and it will create an electrical connection between the component and between the PCB. Okay, component and PCB, it will create an electrical connection. So when you define a paste to the through hole components, the problem is first they will place all the SMD components, then they will solder, later only they will place the through hole components. So first itself, if you define this solder paste, what will happen, this paste will melt and it will close that through hole. There will be clog. Okay, in that case it will be very difficult to rework again in that PCB. You have to remove that clogged area and then you have to place the through hole component. So always remember, you have to define solder paste area for the SMD components only. Don't uh, define solder paste area for the through hole components, because generally for the plated through hole, the through hole soldering method will be mostly dip soldering or manual soldering. In that area you don't need to define any solder paste area. Okay, I hope this you understood this also. And before working on any PCB design tool, you have to adjust the color, contrast, transparency settings in the PCB tool also in the computer. This will help you to improve your like it will help you for the better eyesight, and it will avoid all the issue related to your eyesight, because we are working full time on PCB means it will affect our eyesight also. Remember this. Okay, let's check now how to create a footprint. I have a data sheet here. I have a data sheet here, but I don't have a recommendation. In that case, what I can use is, I am referring this IPC SM782 standard, and I am going to create a 0603 footprint. Here the main important thing is X, Y and C. C is the pitch, X is the width, and this is the size of the pad area, and C is the pitch of the footprint. Like that we are going to create. Remember this length 1 mm, this length 1.1 mm, pitch 1.7 mm. Okay, so let's check. I hope you know how to create a PCB library in Altium. If you don't know, please refer my previous video. In that video the explanation is given. Okay, I'm going to add a new component here. Add. Okay, now we have to place the pads. Go to place pad. Now what is the problem? Here we placed a through hole pad. This you can change. Okay, select both pad. You can press shift and select. Go to change to top layer. Okay, and X is 1.1. Here X is this direction, Y is this direction. Okay, 1.1, Y is 1 mm. Okay, and always make sure you are working in the same unit which is mentioned in the datasheet. So if you want to change the unit, you can press Q. Okay, not here. If you press Q, you can change the unit. Now it is changed to mils. Now again I am going to press Q. Now it is changed to mm. Okay, now we have changed the dimension 1.1 by 1 mm. Okay, 1.1 by 1 mm, but still the shape is not changed, right? What you have to do, you have to again select the pad, change to rectangular. Now it is changed, and you have to change the pin number 1, 2. There are total 2 pin in our component, so you have to define this pin number. Now what is the pitch? Pitch is 1.7. So 1.7 is from here to here. So from origin it is 1.7 by 2. This distance minus 1.7 by 2 that you have to define. That is around 0.85. Y location set to 0 for both. Okay. X location. For right side pin it is 1.7 by 2. 0.85 mm. This is minus 1.7 by 2. Okay, now you can measure using Control M. Pitch is 1.7 mm. This length is 1 mm. This width is 1.1 mm. Okay, I hope you understood. Okay, now you have to define the solder paste and solder mask area. Here go to top paste, So my recommendation is you have to use the same area of the component. Okay, so solder paste area, here it is rule means it will adapt the value which you will mention in your PCB. If it is manual means you can define here itself. Okay, a rule means you can see it is 0.102 mm increased. Okay, so what you have to do here, you can set to manual, you can set to 0. Okay, top solder. Okay, we edited the top solder only. Solder you can set to rule, and so paste you can set to manual. So here you can see it is manual 0 mm, rule also it is 0 mm. You don't need to change. So make sure you change, you set the solder paste opening is 0 mm. Okay, if it is higher value then you have to reduce. Okay, for SMD components, because solder paste should be within that top pad area. Okay, and solder mask expansion, you can see here 0.102. So generally there is a standard value that is 0.07 max around. So let's check what is this now. Here what, as per the rule, what is the mask expansion? You can use Control M from here to here. X distance is 0.1 mm. Okay, this is around 0.1 mm, 0.102 mm is there. You don't need that value. You can reduce that. Click on both pad, change the solder mask expansion to manual, change to 0.07. Okay, all around. Now you can see it is reduced. That's it. We defined our solder mask opening. We defined the solder paste opening. This violet color is solder mask, purple color is solder mask. So this is top paste, that is also we defined. Okay, that is all about the pad. Now we have to place the silkscreen top, assembly top, 3D model, designator, courtyard. So silkscreen top you have to set to top layer. If you click here, this will be our active layer. Okay, top layer, click on place line, top overlay, line width. Okay, this is very important. This is what I am going to show you. If you are not defining a proper line width, finally in PCB it will be look like this. You can see here, just not neat, right? See 1 1 2 5, that is not neat, and all this line is not neat. If you want something like this, a proper beautiful silk screen, then you have to define the minimum line width. So my recommendation is minimum you have to use 1.15 mm. Okay, maximum will be depending upon the aspect ratio of the component. Okay, and there are some rules like silk screen should be 0.2 mm clearance from the this thing. Okay, that also there. So I am defining like this the silk screen, and silk screen it can be in any form, like here I am using like a boundary silk screen, but some standards refer like you can use something like a line only, like here and here you can place line. For example, I will show you. In this they are only using two dotted line here for representing the silk screen. Okay, so here I am going to define this. Maintain, always try to maintain minimum 0.2 mm clearance between silk screen and the pad. Okay, here it is, our grid is 0.1 mm. You can see 0.1 only here I am maintaining. So this you can adjust, and this also depending upon the which type of density level you are going to use. Okay, silk screen is defined. Now placement courtyard. So placement courtyard I tried to maintain at least 0.5 mm clearance. Okay, from the PCB edge, that you can define in mechanical 15 layer. So again, if you don't need to route this, what you can do, go to top layer, press tab to select that layer only, copy with respect to sender, then come to mechanical 15 layer, then edit, paste special, paste on current layer, paste. Now if you press shift S, you can see it is pasted in mechanical 15 layer. Okay, press again shift S to see the full components. So enable mechanical 15 only for now, and the clearance should be around 0.5 mm clearance. Okay, this is also depending upon the density level. 0.1, 0.2 is there. So this is for 0.2, 0.5 mm. Okay, it will looks like something like this. I'm not going to adjust now, but always remember courtyard 0.5 mm clearance, silk screen 0.2 mm clearance from the edge of the component pad. Now we place the courtyard, we place the silk screen top. Now you have to place the pin 1 marking, sorry, origin marking. Okay, origin also we marked. This need not to be 0.15 mm, you can change to 0.1 mm. Okay, press tab and change properties together, because this is not going to print. Okay, this is for the clearance representation only. You can change to 0.1 mm now. So both details we have added here. Then mechanical 13. We can use mechanical 13 for 3D model and mechanical 29 for assembly top. So here I am going to use mechanical 1 for assembly top. So what you have to do, assembly top is the area of the component. Suppose if our component is this much area only, then you have to define assembly top like that only. Okay, but I am not going to refer datasheet now. I'm just showing you how will be the assembly top. Okay, assembly top something like this it will come. So the actual component will be sitting like this on top of this footprint. That is assembly top. And if your component is having polarity, then you have to represent the polarity also. For our case, this is just an assembly component without a polarity, so we don't need to mark this. So assembly top is defined. Now mechanical 13 I am going to use for 3D model. To place the 3D model, go to place 3D body and select the 3D model. And from where you will get the 3D model? You will get the 3D model from supplier website. Otherwise, you can find an alternative part in DigiKey. You can enable, you can download from the CAD model side. Okay, I will show you that now. Okay, I have a component here. Here, if you scroll down in DigiKey, you can see EDA model. Okay, EDA model. From here only you can download. If you click on this model, you can download from here only. Select, then you can select the download format and you can download. Okay, so I downloaded already and I am going to assign this 0603. Open. What you have to do, you have to place this, then right click to disable that. Now again press shift S to see the full view. We have a 3D model, we have an assembly top, and we have sit screen top, we have courtyard. Again here one mistake we made, we don't need to define this assembly top with a 0.15 mm. You can press tab and you can change to 0.1 mm, because this and all you are going to print in PCB. Only sit screen is we are going to print, that's why we defined minimum clear like line width, otherwise it will looks like this, it won't be properly printed. That for that reason only we changed this to 0.15 mm. Okay, now these details we have defined. Now what are the things missing here? The missing details are the designator we missed to add. Okay, what you have to do, select the top overlay, place string, and here this X you can see, right? Click on designator. Then you have to place the designator. Okay, once you place the designator, you can change the this name and all, and you can change the text height. I'm going to change to 1 mm. True type I'm going to change. This you can change. Okay, so I'm going to set to like this. Set with respect to origin. That is one mother. Otherwise you can set like this. Okay, so I am going to set with respect to origin. Now you have to place designator in assembly top also. Enable layer, then place string, designator string, place. Same thing, you have to change the type. 1 mm I am changing true type. Okay, this is also you have to place like this. So we have placed everything. Now then again press shift to S to enable all layer. Now what thing we missed here? We missed to adjust the 3D model. Press 3, you can see the 3D model here, and here right click, press Ctrl and right click to see like this, press shift to tilt like this. Okay, you just need to check whether it is placed properly or the height and all is properly. So what we will do, minimum 0.025 mm height gap you have to define. That and all is advanced settings. Otherwise you can check whether it is properly sitting or not like this. Okay, sometimes this 3D model, what will happen, it will rotate something like this model. There is some problem with the model, means how they define the axis, in that way only it will sit like this. Okay, sometimes if it is like this, when you have to adjust these settings so that it will sit properly. And if you click this 3D model, you can see the standard height. This is what I mentioned, 0.025 mm you can enter. So you will see how actually the component will sit. Now you can see a gap, right? Between the board and the component there is a gap. So this gap also you have to define. Then if you want to go back to the 2D view, press 2. So that view option you can change here, 2D, 3D. So that's all about this PCB footprint creation. So you created the PCB. Now you can save this. Press Ctrl S. Once you create the PCB footprint, you can open the schematic library. You can select the schematic symbol and you can assign the footprint. I hope this video is useful for you. If you like the content, please like and subscribe my channel and support my channel. Thank you. Have a nice day. Bye.